question 5. What are the main properties of ionic compounds? Okay. So, main properties of ionic compounds. Okay. So, with this, actually, the first property I like to always point out is what they're actually made of. Ionic compounds, by definition, have to be a metal, okay, with non-metal, okay. That is one of the properties that you should be looking at first glance. When you see a molecule, like, and the name and everything, you want to check if there's a metallic part and a non-metallic part, okay, because that, in a sense, will tell you right away that's an ionic compound. So what comes with that? Because we have metal bonded with a non-metal, it goes a little bit deeper than that, but the point being is that one of the properties is that they have, as you guessed it probably, ionic bonds, okay? And this actually comes from the electronegativity. So that's actually what I wanted to discuss. So electronegativity is pretty much the electron affinity, how much it wants to have an electron. I mean, like, take an electron from its surroundings. So you see here the metals, when you look at the electronegativity, okay, like sodium, for example, it's quite low, okay? We have 0.93. And then when we go ahead and try to bond it with something like fluorine, right, which has a high electronegativity, that's 3.98. So the range for ionic compounds usually start around at 2 electronegativity. Anything surpassing that, you know, which this calcium fluorine or even like sodium fluorine does, like sodium fluorine, it's just going to be an ionic compound because it passes that 2.0 threshold. There are some ionic compounds that are more like the 1.6, 1.8 thresholds, but it still counts ionic because it's still a metal with a non-metal, okay? So what this electronegativity difference does is that if we took the example of the sodium fluoride, right, is that it would kind of look like this, to where when you do the Lewis structure, the fluorine would actually just hog all the electrons, okay, to where it's more like this. You have just literally a positive side and a negative side, because the sodium has literally given its electron away. It's not like they're sharing it or anything. The fluorine has just taken it. So this is the type of bond that ionic forms. Now, with that being said, ionic bonds are the hardest type of bonds to break. Aside from like metallic bonds and stuff, and that one's a whole different discussion topic. But if we're going from like, non-polar, covalent, all the way to ionic bonds even surpass things like hydrogen bonds. So because of the hardest bonds to break, ionic compounds are usually, okay, have the highest melting point / boiling point. Okay, because of the fact that these bonds are really hard to break, okay? And because as well, there's situations like that, some of them have a very easy time dissolving in water because they have exactly a positive side and a negative side. But this is really the ones I want to emphasize. The properties of it is that it's a metal with a non-metal. They are composed of ionic bonds, which are the hardest bonds to break, and they usually have the highest melting / boiling point. But it just depends also on like the size of the molecular compound as well, okay? So let's see what they say. Strong attractive force between a cation and anion. Yep, metal and non-metal. Metal is serving as the cation, and this is serving as an anion, okay? Strong refracting points, which is highest or high melting and boiling point. And I'm not sure about this part, but there's something else I guess you need to know as well, that high enthalpies of fusion. So exactly like to actually form them, you need quite a bit of energy. And ionic compounds are also hard brittle, so it's kind of like you'll see a lot of them like in powders or like like in kind of like crystallized structures. That's usually what we see for ionic compounds. An example would be like salt, for example, NaCl. And exactly, it dissolves typically, and they're electrically charged because exactly we have a cation here. Hence why it dissolves like in water, for example, because it has has a polar and non-polar sides. Has a positively charged and a negatively charged side. So the sodium would go towards a negatively charged side, which is the oxygen and H2O, and the fluorine would go towards a positively charged side, which is a hydrogen and H2O. Okay, so yeah, these are just really all the main properties of ionic compounds. And with that being said, I think the ones you need to highlight to differentiate from the other compounds, like the covalent compounds, you want to make sure that you are identifying that you have a metal and a non-metal. Sorry. You want to understand also that if you're going to list out a bunch of compounds, usually the ionic compounds are the hardest bonds to break, and exactly they usually have the highest melting/boiling point. Okay. All right, let's move on to question 6.